Hi guys, so welcome back. Now let's move on with the implementation of hoops in Python. How do we implement hoops? Very simple. We need to understand the different techniques Python has followed in order to write classes, create objects, and how we can pass objects, how we can receive objects. If we learn that, we can start implementing hoops on that also. Getting that? So let's understand this. If at all I have to implement oops, first of all, I should know how to write classes. So a class can be written using the keyword class. And remember one more thing, whenever you write a class name, the class name should always start with an uppercase. Now, this is not from Rosum or Grady, or James Gosling of Java or Stroop of C++. This is given by Alan Kay and Grady Butch, these specifications. So, languages don't bring specifications, they follow specifications. So, standards and specifications are drafted by the creators of OOPS. So, here, if at all I have to create a class, then I have to say class like this, living object, for example. Again, the naming convention still the same. You cannot start a class name with a number or a special character. Underscore can be there, it's the start and the end in between also. And then once you have written the class name, then to end the statement you need to give this colon ends the statement. So here you have declared a class, and inside the class you can write your properties, your methods, whatever you want you can write. Like for example, I can say here age equal to 20. I can specify, and again it has to be indented properly, like how you wrote functions. Similarly, here you can also define methods, define met of. And there is a difference here. See, we have something called as self. Now, what do you mean by self? Self means current object. So every function should have that parameter. That's compulsory. You cannot write a method without that self parameter in Python. So here you have this, and let me just have a print, met called of living object. Let's have this. And if you want, you can just print that because that's a global variable, very much accessible. So if I have this, fine. Okay. To access that global variable here, we have a difference because it's outside the function. You have to say self dot. So self dot age will only be able to access that global variable. In other languages, this if you want to have a alternate for self to understand it better. In Java and other languages, we use the keyword this. Self and this both are same. This refers to current object, self also refers to current object. Getting that? So if you want to refer the global variables, you have to make use of the keyword self here. Self is the current object. Okay. So here we have a class. Now how do we create an object of this class? Pretty simple. So I can say human equal to living object. That's it. The object is ready. Now, once the object is ready, now you can very well bring out the properties and methods of that particular object. So you can say human dot met. So this will call the met method of that particular living object. Do I have to use this word object? No need. No need. And remember one more thing: all classes in Python inherit a galaxy class called as object. We'll come to this later, but please understand they all come under hierarchy by default. This class living object is actually a kind of object because it inherits object. Okay. So not only this, you can also have one more thing called as a constructor in a class. A constructor is a self calling method. On the creation time, during the creation time, the constructor will be called. Like for example, here I can give like this def two underscores, two underscores, and the method name should be init. The method name should be init. This method is called whenever an object of this class is created. Like for example, here you can say object created just to see when it is called, and it is called automatically. The moment you say living object, this gets called. See this? And if I'm going to create one more object, or several times you create like this, so you can also do like this is called as anonymous object, a nameless, a name is not given. There is a named object. If you do so, three objects are getting created, three times the object created will be called, printed. Why? Because three objects are created. That means it is self-calling method. Constructor is not called by you. The moment you create an object, the constructor gets called. Now, what is a constructor, guys? See, for example, a mother delivers a baby after 9 months. The moment the baby is born, the baby could cry. Now, the initialization of the cry happened during that 9 months, right? Similarly, a whale's baby can swim the moment it is born. The initialization of swimming happened during the construction time. So here comes a definition given by Grady-Booth. Grady-Booth says what is needed for the mere survival of the object is given in the constructor. Understand this. What is needed for the mere survival of the object is given in the constructor. Because for a baby, if it does not cry, it is called as a still baby or a dead baby. For a whale's baby, if it cannot swim, it will cannot survive. Right? It cannot. It will die. So minimum needed things which are needed for the survival of the object can be initialized in the constructor, can be placed in the constructor. Now initializing you are saying, but you are just printing something, sir. You can ask me, can I initialize something? Yes, you can initialize. For example, this age can be initialized here. You don't need to give anything here. Say find age, and I can pass here. Let me. I can pass here 20, for example, and then I can say self dot age equal to age. Self dot age equal to age. I've initialized the age property. That property I can read here. See this? I can also initialize a new object, living object of 30 dot, like this also you can call. Is anonymous, nameless object. So if you do so, this is coming as 30. So two objects are created. So please understand, guys. Fine. Once you have written a class, n number of objects can be created. A class can have properties, can have constructor, can also have methods. Can I have more than one method? Yes, you can have more than one method. Can those methods be overloaded? No, you cannot overload. For example, this method you cannot recreate it again. Even if you give a different parameter, fine. Let's say I have given a different parameter. Okay, still if I'm going to run this, see, fine, it cannot. It is asking like, see, this method is ignored, this method only will run. So if at all I have to run this, then I should say 1 1. Fine, then only this method we can now never ever be called. It can be fine. Even if I call this without parameter, it is going to throw me an error. See, the last method which is there, which will take over. The previous methods will be, I mean, discarded. And one more thing, similar thing happens to constructor also. You can have only one constructor, you cannot have more than one constructor. See, even if I have one more constructor, this is not going to work. This is not going to work. Like for example, if I have this, fine, if I'm going to call this living object without a value, now this is also going to throw me an error. It does not. It has to go with a value. It has to go with a value. Then only it will accept. Then only it will accept. Getting it. And met may you have to have a value means it will accept. Okay. So please understand these concepts very well, guys. So how with overloading is not supported by Python. So we have proven that. And in constructors are there. Constructors can also cannot be overloaded. That also we have proved. And you also learned self. Self means that this operator refers to the current object. And here we have created a name object. Here we have created a anonymous, nameless object. Got it. The next one more very interesting thing is the concept of pass by value, pass by reference. Pass by value, pass by reference is like when values are passed in a method, like here we are passing, right, a value. When a copy is passed, but when objects are passed, a copy is not passed, the address is passed. Please understand this. Difference between me telling like this, somebody asked me, fine, how much money you have, I say 100 rupees. Now this is value. But now I say I have 100 rupees in my pocket. That means I've given the address. Or I can say I have 100 rupees in my bag. I've given the address. Now, if he wants, he can change that. He can pick up that 100 or add another 100. Either thing is possible. Correct? If I just say I have 100, if he thinks 50, it is his problem, not my problem. But if I say the address where the 100 is, he can make changes. So pass by reference is passing the address, pass by value is creating a copy of the value and passing. So I'm passing a copy, right? 100. So one more copy is created that you receive. Getting it? We call this as Chinese whisper game, where one word is said to one student in a bunch of students. For example, let's say I've said Indira Gandhi. After the 20th student, the 20th student will tell me Lionel Messi, because the copies keep changing. And my word still is Indira Gandhi, right? This is what we call as pass by value. My word will not change, but the copies can change. That will have no effect on my word. My word will still be Indira Gandhi. But just imagine if I tell you the address of where sweet box is and I leave. Now, sweet, everybody likes it. So people will go eat, have it. And then when I come back, so fine, no sweet will be there. Correct or not? Fine. So something like that. So pass by reference is passing the address, pass by value is passing a copy. Now, shall we prove this? Fine. For that, I'm creating a class called Laddu, and I have two classes. In one class, I have a method PBV where I am accepting a property value. In another, I am accepting the object address. So if I change the property, the original does not get changed. But if I use the address and change the property, the original gets changed. That is what we are going to prove in this. See here. I'm creating a class called Laddu. Okay. I say size equal to 10. I'm creating class pass by reference, and I have a method def pbr which accepts a Laddu. This is the object address itself. Now I say Laddu dot size equal to fine 5. Now I create one more pass by value. Here I say def pbv comma size. Here I'm just getting the value. So size equal to 5. That's it, guys. I have two. One is I'm getting the address, another I'm getting the value. Now let me write a demo class where I will try to, the best part of Python, even without demo you can run. See here, I can straight away run. Normally other programming languages will write a demo, will write a main method, then we'll execute. But here it works just like that. I can create a Laddu, my Laddu equal to Laddu. Laddu is created. Now if I'm going to say print size of Laddu before, let's say PBR, my Laddu dot size. Now I pass the value, comma. I pass this Laddu to pass by reference. How do I create a pass by reference here? PBR equal to pass by reference. Similarly, PBV equal to pass by value. So two objects, right? Now I say PBR dot PBR of my Laddu. Now I say, very important guys. This one, if you understand, no, plenty of things will get clear on object-oriented programming. So this is size of Laddu after PBR. See, please understand. I'm passing the address. Address is received here. So if I make a change, the original will get changed. See. But this is not the case with PBV. Now the same thing, let me do it with PBV. Before PBV and after PBV. Right? Here I'm going to say PBV, and here I don't pass laddu, I pass size. So this is what the difference is. Here I'm passing what? Address. I'm passing. Here what is that I'm passing? Fine. I'm passing when value is value I'm passing. So when I pass the value, copy is sent. So the original will remain same. Copy is changing. Fine. But the original is still 10 only. See this? Say in one movie, in Tamil movie, when two comedians will meet in jail. So one comedian will give the address of his house to the other, thief. So the cellmates, the jailmates and all will say, "Don't give because he's a thief." They say, "No, no, nothing will happen. I'm just giving the address. What's the problem?" So the thief who got the address gets released 1 day before. So he has the address, right? So he goes to the house, clean sweeps everything. The next day, the one who gave the address goes to his house, finds nothing in the house. So address is very dangerous. Don't share the address. If you share the address, then they can have access to you. So the one famous one, one it, people who give threats right to others. I mean, gundas they are called as. So one person gave me a psychological solution on how to put a fear factor in somebody. So if you are meeting somebody, you want to put a fear factor under him. So he you scare him. He gave a super duper idea. He said when you meet somebody or if somebody you want to scare or if you want to ensure that no you dominate, then when you have a no I mean conversation, tough conversation with the other girl, say you are so and so, right, and you live in this area and your family is this and your father is this and your mother is this, your brothers are this, I know everything about you. Now give this information, the other person will get scared. That's what he told me. No, that was very scary. Fine, that was very scary because once you know the address of fine you where I live, where my parents live, where my children live, where my relatives live, that looks little scary, right? Because once the other person knows the address, then it's a dangerous call altogether. Correct? Fine. That's what addresses are very dangerous. Don't share the addresses. When you share the address, the other person can change it. Only values you would give, no issues, nothing will happen. Got it, guys? So this is pass by value, pass by reference. Kindly work it out, kindly check this out. This is a very important concept. We use this extensively. Okay. Last but not least, here we are going to talk about multiple inheritance. Now, Python is one language which has similar to C++, of course. Java does not support this. So similar to C++, Python also supports multiple inheritance as well as multi-level inheritance. See, you can have a inverted V as well as this V also in Python. See, in Java and all, you can only inherit one parent class, one super class. When Python, you can inherit two parent classes. We call this as multiple inheritance. Not only that, you can have multi-level inheritance also. So we are not going to go beyond this. Our syllabus for this basic OOPS is going to stop with this. But definitely in level 2, we are going to deal more on this. We are going to learn design patterns also on this. So that we'll see in level 2. As of now, let's master this until this. Okay, how do we create such hierarchies? So here I have given you the code example. So class X, Y, Z are independent. They are by default inheriting object. I don't need to specify that. But class A inherits X and Y. So how do we say that? Class A, and then you got to see this mouse pointer. Within brackets, you got to say X comma Y, like a tuple. You got to say. So when you say X, Y, it means you are inheriting X and Y. Similarly, B is inheriting Y and Z. And look at M. M is inheriting A, B, comma, Z. So pass, you know very well what is pass. Pass is just going to Fine, say that I have nothing to write inside that, just like that, leave it. And MRO basically fine will return that particular class detail. You can see here M class B, fine, like this. Could you see that? If I say m.mro, it returns all the classes which it inherits. M extends is B, fine, like this, right? The all the classes which it has inherited. So how the inheritance has happened, getting that? So as such, this is more than sufficient for you right now. So what you have learned in this slide is, if at all you are given a hierarchy, how to give that hierarchy, how to create that hierarchy, is what exactly we have specified. So definitely after covering little more modules and little libraries, again we are going to get into Python level 2, where we are going to talk about more on object oriented programming in Python. Till then, fine, that's all we have with respect to OOPS as well as classes and objects is concerned. In the next videos, in part 3 videos, we are going to talk about the modules and little bit advanced concepts of Python. And then we are going to go into level 2 of Python, where we are going to talk. But that's going to be fine, very little advanced, where we are going to talk more about how Python can be used to solve complex problems. Okay. Thank you very much. See you in the next video. Thank you.